Good morning, students. We will continue with our miscellaneous exercise of integral, and till now we have discussed till sum number 26. 27th also you people can do easily. I have given the hint in the previous class. Now we will discuss here sum number 28. So sum number 28, I have taken the statement here. The limit are from pi by 6 to pi by 3, that means 30 degree to 60 degree, sin x plus cos x, and denominator is root of sin 2x. So here if we just observe, sin 2x we have, right, and in the numerator sin x plus cos x we are having here. So what we will do here, I have to make some arrangement in the term, if I can do here in the denominator, such that the sin x plus cos x numerator term I can get as the derivative. Now this sin 2x, right, this thing we have done like many times in our sums in integral also. Sin 2x, when I write down, we say it is 2 sin x cos x, and 2 sin x cos x when we get, if I do sin x minus cos x whole square, then also I get 2 sin x cos x term, and if I take sin x plus cos x whole square, then also this term 2 sin x cos x comes. Okay, and now I will go for sin x minus cos x. Reason being, we know the derivative of sin is cos and the derivative of minus cos is plus sin. So if I can write down this sin 2x term in terms of sin x minus cos x, then our problem will be solved. So when we write down this sin x minus cos x whole square, we get here sin square x plus cos square x minus 2 sin x cos x. Okay, so minus sign we can easily adjust, there is no issue, and sin square x plus cos square x we can write it as 1 as we have our identity. So what we are going to do, we will first of all convert or rewrite our denominator in this form. So let us write down this thing. I have done the rough work only. Let us write down our integral. It is pi by 6 to pi by 3. Numerator we will not make any change, and in the denominator, how we are writing, we want sin x minus cos x whole square, that means sin square x plus cos square x, this is actually 1 minus 2 sin x cos x I am getting. Okay, and minus sign is there, so minus sign if I write down here, I am getting the plus term, right? So this plus term which we already have, this issue will be solved if I take this. So minus of 1 minus 2 sin x cos x we are getting. Now the next thing, minus sign is there and minus 1 is there, so we have to add 1 also. So what I am going to do here, I will add 1 and this 1 is subtracted, this minus 2 sin x cos x I am writing. The rough work I have done here in this bracket. Okay, so dx will be there. Clear? And this 1 minus 2 sin x cos x, how it is coming? By sin x minus cos x whole square. So we will write our integral then, pi by 6 to pi by 3, it is sin x plus cos x dx whole divided by root of 1 minus. Now this bracket I will replace by sin x minus cos x whole square. Okay, now what we will do, we will put this sin x minus cos x as y, and when I differentiate cos x plus sin x dx, it will become dy. So this will become, numerator is dy and denominator we will have root of 1 minus y square. Integral has been simplified. Now we have to change the limits. So let us change the limits when x equals to pi by 6. So what will be y? Sin pi by 6 minus cos pi by 6. And sin pi by 6 is 1 by 2. Cos pi by 6 is root 3 by 2. So here we will have 1 minus root 3 by 2. It will be our lower term, lower limit, And the second limit we have, when x is equals to pi by 3, then y will be sin pi by 3 minus cos pi by 3, and sin pi by 3 is now root 3 by 2, and cos pi by 3 will be, just take the opposite values actually, on 30 degree and 60 degree it will be 1 by 2. So here we will have root 3 minus 1 by 2. Limits are also changed, so our integral will become, here it will be 1 minus root 3 by 2 into root 3 minus 1 by 2. This is dy divided by root of 1 minus y square. And this integral, I hope now by this time everybody knows, integral dx upon root of 1 minus x square is sine inverse x. So here we will have sine inverse y. Okay, so integral, it will be sine inverse y. Let me write down here, and the limits are 1 minus root 3 divided by 2 to root 3 minus 1 by 2. Now the only thing is, we have to apply the limits and get the answer. So when you apply the limit, it will be sine inverse of root 3 minus 1 by 2 minus sine inverse of 1 minus root 3 by 2. So from the second term, if I just take the minus sign common, I will get 2 times of this thing. So let us complete the sum on the next page. Okay, before going to the next page, let me tell you again what we have done, because we are not getting any connection between, in the numerator we have sin x plus cos x, denominator is product of terms. So this term, product of terms, if I can write as the sum of terms, then our problem will be simplified. So for that, we know sin 2x can be written 2 sin x cos x, and this thing when I will get, if I have sin x plus cos x whole square, or if I have sin x minus cos x whole square. I am not taking sin x plus cos x because I need sin x plus cos x as the derivative. So I will put sin x minus cos x square, and then I will get sin square x plus cos square x minus 2 sin x cos x, and minus sign we can easily adjust. So this is what we have done. After this simplification of the denominator, we are just making our substitution as sin x minus cos x, we are putting as y, corresponding to which numerator will become dy. And now we are changing the limits, and when you change the limits and integrate, our integral is coming sine inverse y. The limits are as we discussed. Now let us apply the limits. So we have this function sine inverse y from 1 minus root 3 by 2 to root 3 minus 1 by 2, and when we apply the limits, it will be sine inverse of root 3 minus 1 by 2 minus sine inverse of 1 minus root 3 by 2. There is just difference of minus sign in the numerators, so if that minus sign I take outside, I am getting this thing plus sine inverse root 3 minus 1 by 2, and this is 2 times of same, and this will be our answer. That's it, right? I hope you people understood the sum. This was sum number 28. Sum number 29 is very simple if you just look at the statement. Sum number 21, integral is given 0 to 1, and we have dx upon root of 1 plus x minus root x. What we will do, just rationalize it. When we rationalize this, we will get here 1 plus x plus root x divided by root of 1 plus x square minus root x square dx. Okay, and this, when I open the means square and root will get cancelled, so 1 plus x minus x, the denominator will be left 1 only, and we have these two terms in the numerator. So this integration you people can easily do. It is actually 0 to 1, 1 plus x power 1 by 2 plus x raised to power 1 by 2 dx. By power rule only you will integrate, and after that just apply the limits and you are getting your answer. You people can complete this sum. I am just giving the hint. So this is sum number 29. Now the next sum number 30, is very important sum. So let us discuss sum number 30. Okay, it is quite important. Sum number 30, sum number 26, 27. So these are the sums which are important sums, and they come also quite often. So let us discuss now sum number 30. Okay, I have noted down the statement sum number 30. Sin x plus cos x upon 9 plus 16 sin 2x. So if you just observe the statement, it is very similar to sum number 28 statement. There also numerator was sin x plus cos x and the denominator was root of sin 2x. Here we have two constants like 9 plus 16 times sin 2x. But we will just follow the same thing as we did in sum number 28. This sin 2x, I can write it as again sin x minus cos x whole square, right? And that I will convert it again into that form, and then once again we will be putting sin x minus cos x as y, right? So let us do this sum. So what we are going to do here, once again sin 2x, that means it is 2 sin x cos x, and how I will get it, sin 2x, it will be sin x minus cos x whole square. If I do, I am getting here 1 minus sin 2x. Okay, I hope it is clear. So this thing sin x minus cos x square, we are getting 1 minus sin 2x. Now the next thing is how we will write this sin 2x in this form. Okay, so what we can do here, I just want sin 2x, right? And we are having the terms extra. So what we will do, the term which I want, if I write down the other way, so here let me expand this thing for you people. Sin square x plus cos square x minus 2 sin x cos x. Okay, so this sin 2x can be written, then it can be written as sin x minus cos x whole square. Okay, and then what we will do, from this thing we will just subtract sin square x plus cos square x, right? Or sin square x plus cos square x, we will subtract this thing, you people, because minus sign we have to adjust. So if I do it the other way, I can write it as sin square x plus cos square x minus, it will be sin x minus cos x whole square, right? So this is 1 only, so it will be written as 1 minus sin x minus cos x whole square. And then this sin x minus cos x I can put as y, and sin x plus cos x dx will become dy. I have taken much time to explain this thing. Okay, if I hope it is clear now. I have explained the first way. If I take this term first, I am getting negative sign, so we will just change the order of the terms so that I get positive sin 2x. Okay, so let us make this arrangement here. So our integral is I equals to, I am writing here 0 to pi by 4. This is sin x plus cos x divided by 9 plus 16 times. So here what I will do, 1 minus, because sin square x plus cos square x is 1 only. So here I will do 1 minus sin x minus cos x whole square, and dx is, let us write down dx in the numerator itself. So this sin 2x I have written this way, and now this sin x minus cos x we will put as y. So sin x minus cos x, it will become y, which implies cos x plus sin x dx, it will become dy. And now this will become dy, 9 plus 16 1 minus y square, and we will change the limits also. First, when x is 0, let us substitute. When x is 0, that means sine 0 minus cos 0 will be y. So the value of y is coming -1. Second, when x is pi by 4, y will be sine pi by 4 minus cos pi by 4. 1 by root 2, 1 by root 2, it will be 0. Right? So our integral will become, this will be, the lower limit is -1, upper limit is 0. This is dy upon 9 plus 16 times 1 minus y square. Okay, now we will just simplify. 16 y square, 16 plus 9 is 25. So we are getting dy upon 25 minus 16 y square minus 1 to 0. And I hope you people can do it. I will just make the numerator of y square as 1. So we will divide we will take 16 outside, and we are getting here 1 by 16 outside minus 1 to 0, dy upon 5 by 4 square minus y square. And you people can apply the formula dx upon a square minus x square, which is 1 by 2a log of a plus x upon a minus x. So that calculation part I am again leaving it for you people. You have to just apply the formula, and after that just apply the limits. You are getting your answer. This was sum number 30. Okay, now I will give you the hint for sum number 31 also. So let us do that. So in sum number 31 also, once again we have sine 2x into tan inverse of sin x. So tan inverse of sin x is there. That means this sin x I can make the substitution. And sin 2x also, if I expand, I will get 2 sin x cos x, right? So I think you people will get it. So 0 to pi by 2, it is 2 sin x cos x tan inverse of sin x dx. So if I put this sin x as y, then cos x into dx, it will become dy, and correspondingly we will change the limits also. So let us make the substitution. We will put sin x as y, which implies cos x dx will become dy, and let us change the limits. When x is 0, sin 0 is 0, so the value of y is 0, and when x is pi by 2, sin pi by 2 is 1, so y will be 1. So these are our new limits. So our integral will become 0 to 1, and here we have 2. Let us write down outside 2. It will be y tan inverse y dy, y into tan inverse y. So we will integrate by parts, and according to I late, this will be our first function, this will be the second function. We will integrate by parts. So let us do that. First function as such, integration of second, that is y square by 2 minus integral derivative of first, it is 1 upon 1 plus y square, integral of second dy, 0 to 1, and here also limits are 0 to 1. So here y square upon 1 plus y square, we can add 1, subtract 1, and correspondingly we can do the integration. So we are getting here y square by 2 tan inverse y. I am keeping this term as such, minus 1 by 2 as such. So what we will do, 1 plus y square minus 1 upon 1 plus y square dy. When you just separate the terms, our answer will be there. It is y square by 2 tan inverse y. We will write down the limits. Here also limits are there, minus 1 by 2. So 1 upon y square plus 1 upon y square is y only, means integral will be y, minus 1 upon 1 plus y square integral is again tan inverse y, and the limits are 0 to 1. So we will just apply the limits. So lower limit will make it 0, lower limit will make the terms this term 0, and tan inverse 0 will be 0 only. we will be just putting the upper limit. So tan inverse 1 means pi by 4. Here 1 by 2 pi by 4 minus 1 by 2 into 1 minus again tan inverse 1 means pi by 4. So let us apply the limits. So what we are getting here, it will be, the first was y square by 2 tan inverse y 0 to 1 minus 1 by 2 outside, it was y minus again tan inverse y 0 to 1, right? So let us apply the limits. So this will be 1 by 2 into tan inverse 1 minus 1 by 2 as such, 1 minus tan inverse 1. So we are getting here tan inverse 1 is pi by 4. So here pi by 8 minus 1 by 2 minus minus plus again pi by 8. So it will be pi by 4 minus 1 by 2. This should be our answer for sum number 31. Similarly, sum number 32. Okay, here let me give you the hint for sum number 32. The integral is 0 to pi x tan x upon secant x plus tan x. So what we will do here, we will just apply the limit, means the property also you people can apply, 0 to a property. If you remember 0 to a property, what the property says, so if I apply the property 0 to a f of x dx, it will be 0 to a f of a minus x dx, and we know tan pi minus x will be minus tan x, because pi minus theta is second quadrant, and secant of pi minus x will also be minus tan x, right? So we can apply that property, as the functions will not change, only signs will change. So I am mentioning the property here, 0 to a fx dx, it is 0 to a f of a minus x dx. So this property we will apply, it will be 0 to pi. In place of x, what we will get here, pi minus x into tan of pi minus x divided by, okay, let us mark the given integral as 1, divided by secant of pi minus x plus tan of pi minus x dx. So this will be 0 to pi minus x. Tan of pi minus x will be minus tan x, so this minus sign I have written before this term. Secant of pi minus x will be minus secant x, this also will be minus tan x dx. So if I take minus sign common from the denominator, it will get cancelled, okay, and our integral will become 0 to pi tan x minus x tan x divided by secant x plus tan x dx. If I mark this integral as 2, now x tan x minus x tan x, denominators are same, so we will add 1 and 2, then x tan x and x tan x will get cancelled. We will be left with pi tan x upon secant x plus tan x. Pi is constant, we can bring it outside, and then we can apply our integration, means tan x we can write down sine by cos, 1 by cos. So after taking LCM, you will find integral is becoming simple. So I am leaving this sum number 32 for you people, and I will give you the hint now for sum number 33. Okay, so here sum number 33, we have sum of three modulus functions, mod of x minus 1 plus mod of x minus 2 plus mod of x minus 3 dx. The limits are 1 to, okay, the limits are 1 to 4. Okay, now in 1 to 4 we have to check the signs for all these three modulus functions. Okay, and that if you want we can do one by one also, because some of the functions I can write it as 1 to 4 mod of x minus 1 dx plus 1 to 4 mod of x minus 2 dx, and the third will be 1 to 4 mod of x minus 3 dx. Now we can apply our definition of modulus function over all these three integrals, right? Now x minus 1, at x is equals to 1 the integral will break, and we are already having 1 to 4. So in the limit 1 to 4 this function will give us positive value only. So we will have 1 to 4, and here it will be simply x minus 1 dx. Now this x minus 2, that means at 2 the limit has to change. So when I have x less than 2 it will be negative, when I have x greater than 2 it will be positive. So what will happen here, 1 to 2 I will have minus of x minus 2 dx, and then from 2 to 4 I will have positive of x minus 2 dx. Similarly for the third integral, from 1 to 3 I will have negative of x minus 3 dx, and from 3 to 4 we will have positive of x minus 3 dx. How we have done, let me mention here once again. Mod of x minus 1, right, it will be x minus 1 for all x greater than or equal to 1, right. Mod x minus 2, this will be x minus 2 for all x greater than or equal to, and it will be minus of x minus 2 for all x less than 2. Similarly mod x minus 3, it will be x minus 3 for all x greater than or equal to 3, and minus of x minus 3 for all x less than 3. So we have just applied the definition of modulus function, and now we will just integrate all these 5 integrals and apply the limit. You people will get the answer. I am not going to integrate, all these functions are quite simple, or all are linear functions. X square by 2 minus x, x square by 2 minus 2x, x square by 2 minus 2x, here or definitely signs will change. Minus x square by 2 plus 3x, x square by 2 minus 3x. Apply the limits. Don't club the terms before applying the limits because the integrals are having different limits. Apply the limits and then we will solve it to get the answer, right? Sum number 34. In sum number 34, let me tell you, you people will complete it, okay? And let me give you the hint for sum number 34 and 35. We have integral dx upon x square into x plus 1. The similar sum we have discussed already. I think it was sum number 22, right? So x square, square of linear function into one more function, linear function only. So what we will do here, we will consider the integrand 1 upon x square into x plus 1, and we will write it as a upon x plus b upon x square plus capital C upon x plus 1. By equating and comparing the coefficients, we will get the values of a, b, c. Then the integral will change, and correspondingly you people will be easy, it will become easy to do the integration. So sum number 34 I am leaving. Sum number 35, it is x e raised to power x dx. Integral, the limits are 0 to 1. So here we will apply integration by parts. According to Eilert, this will be first function and e raised to power x will be second function. Just you are doing the integration, and after that application of limits, answer will be there, okay? And the remaining we will discuss in the next class. So you people can do this exercise from sum number 28 to sum number 35. Thank you, students.